This Week in Radio Tech, episode 228, is brought to you by Telos ProStream, the do-it-all, one-box streaming solution. By Lavo, maker of the new Crystal Clear virtual radio console. Crystal Clear is the radio console with a multi-touch touchscreen interface. And by the Axia IP audio driver for Windows, Mac, and Linux. Only Axia connects to so much, so easily. Is there any hope for the AM radio ban? A few major market AM stations still enjoy success, but AM radio is suffering most everywhere else. Professional engineer Ted Schober says there are solutions to help AM stations, including smaller antennas and a transition to digital transmission. Is it already too late to save AM, or can we do it? Hey, welcome in. It's time for This Week in Radio Tech. It's the show where we talk about everything radio technology from, I always say, from the microphone to the light bulb at the top of the tower and everything in between. And, more and more content is being created that doesn't go into a tower. But I think on today's show, we're going to talk about AM towers and what to do with the AM band, how to maybe fix it, how to make, I think they say a silk purse out of a sow's ear, and some people think the AM band has become a bit of a sow's ear. We'll get to that. Our show is brought to you by three terrific sponsors: the folks at Lavo and their Crystal Clear console, also the folks at Axia. I'm going to tell you about the IP audio drivers today, and the folks at Telos Systems, and they are the makers of the ProStream streaming appliance. We'll tell you about those coming up in just a minute. Let me go ahead and introduce our guest. Our guest is a professional engineer. He's the first professional we've actually had on in a while. PE Ted Schober. Hi, Ted. Welcome in. Glad you're here.
Hello there. Well, this is kind of fun. It's the first time I've been on web television. I've got a web television show on my radio station, but this is the first time I've been on one myself.
Well, you're going to enjoy it so much that you're going to be calling me back and say, Kirk, when can I be on again?
Okay.
Ted is going to, Ted, give us seriously a 30-second preview of a couple of the topics we're going to hit on. Wet our whistle a little bit for the things that you're passionate about.
Sure. One of the things that has been my business all along has been AM radio. And the problem with AM radio is multifold, as everybody knows. It's got noise, it's got rotten receivers, it's got rotten content, it's got an awful lot of rotten stuff on the band, which scares everybody away. But in among all of the radio stations that are not doing very well and sound pretty terrible, there's also some gems, and we should definitely consider ourselves in the mode where we recognize that content will bring people back to the band. However, the technology of the band is getting really long in the tooth, and it's time to do something about it. So there have been suggestions and plans and everything else that people have been talking about, some of which may go to fruition and others which will never come to fruition because of the fact that the politics aren't right for it.
Sure. But I'll tell you what, let's pause it there and keep everybody's whistle wet. We'll keep our powder dry through the first spot and then jump right into some of the things that you're talking about and you're passionate about, because I'm passionate about them too. I want to see this band that travels locally and travels far. I want to see it come back and do well. And I got to believe that there's technologies that are more appropriate. But we'll get into that. Hey, I want to tell you first of all about our first sponsor. This show is made possible by the wonderful sponsorship of some people. One of those is my friends at Axia. These guys, they make an audio over IP console system and a number of different audio products that plug right into that. I just got done moving and rebuilding 4 radio station studios or a studio for 4 radio stations in Greenville, Mississippi. Not exactly the garden spot of the world, but you know what? These studios went right together. And one of the things that made the studios go together so well was an invention from the folks at Axia. It's the Axia IP audio driver. This is a piece of software, and they have one for Windows. They actually have several models for Windows of this IP driver. They have a beta version for the Mac. It's on my Mac right now. And they have a version for Linux, which is actually handled by a partner company of ours for proper integration into Linux. Now, the IP audio driver, it takes the place of the sound card. At my radio stations in Mississippi, we've got 7 PCs, some running Windows, some running Linux, that handle audio. and not a one of them are we using the sound card. Gone are the days of messing around with finicky little 3.5 millimeter stereo connectors, or even quarter-inch connectors that kind of do fit in the space of a PC expansion card. No dongles, no pigtails coming and breakout boxes, none of that. It's just another network interface card. That's right. So we take the IP driver and install it in a computer. And to the computer's operating system, it looks like another sound card. Or on our multi-driver scheme, it looks like up to 24 sound cards in that PC. Windows, Linux, Mac thinks that it has one or more sound cards in it. And your applications work with that driver to when you pick out a sound card for it to use, just works with the driver. The application thinks that it's sending and receiving audio to and from a physical a sound card, but it's not. It's actually talking to the driver, and then the driver is packetizing packets to go out to the Axia network, or receiving packets from the Axia network from a subscribed stream and turning that into audio inside the PC. So, for example, we're doing automation, including subscribing to satellite network satellite feeds coming in. We mix with our local liners. This is in the Rivendell automation system. Mix with our local liners and bumpers. Break away from that for the actual spots, and then rejoin the stream that's coming in. There's remix it back in using the computer's internal mixer. So the IP driver, you can add an IP driver for the cost of the driver software and the cost of another network interface card that you slip into your computer. Could be a $15 card that works just fine. So it's an amazing technology. There's all kinds of things you can do with it. And on the website, there is a web page that will give you some ideas of how to use the Axia IP audio driver to solve some problems that you may have. Go to axiaaudio.com/soundcards. Plural, sound cards. So axiaaudio.com/soundcards. And there's some great ideas there on what you can use the Axia IP audio driver for. I highly recommend it. So many things you can do with it. One of the things we're doing is recording all of our stations using iProfiler. No wiring, no XLRs, no 3.5 millimeter connectors, just the same network card that we talked about earlier, and make it subscribe to the streams we want to record. Hit the record button, and bam, we're recording up to 24 streams at the same time to the hard drive. Check it out on the web, axiaaudio.com. Thank you very much, Axia, for your support of This Week in Radio Tech. All right, Ted, let's get back at it now. We've got a good 20 minutes before our next commercial announcement. AM band.
Before we get off the commercial,
go ahead.
Before we get off the commercial, you just mentioned something that I'm kind of excited about. I think I'm going to go ahead and do this. One of the problems that you have with the audio cards is whenever you go to analog and back, you always pick up noise and distortion. You can't avoid it. And every time you recode to a different codec, you lose quality.
Sure.
So by keeping everything in the digital domain between computers and the external systems, and like right now I'm using a radio systems board at my little radio station. I come out of the Rivendell, go into the board, go back over to the server, and then from the server I turn back into digital again to make the stream and to do the STL. Well, that's got too many conversions.
It does, yeah.
We go with high rate MP3s, and I'm hoping to go to Opus pretty soon. But the fact is that every time you make a change, you lose something. And while you could say, oh, on AM it doesn't matter, well, it does, because everything that you lose, you never get back. You can never gain back what you lose. And by keeping in the digital domain, even in a regular Windows 7 machine, and not go out on the sound card and not use unbalanced, which picks up hum particularly, you are, and also RF susceptibility if your studio's at the transmitter, you very much are in a very good way, because the fact is, shielded Cat 5 does very well in a reasonable RF environment.
Well, one of the first uses of the IP driver, and this was like 10 years ago, I visited a station in Southern California that had 2 AM transmitters on site with the studios. And the studios were very old, gorgeous old Art Deco building, but just terrible wiring and miles of it. Lots of antennas hanging around with the audio. And they were trying to stream, and they just kept getting RF in the stream. And so I said, tell you what, let's put the IP driver in your computer. You can still use whatever streaming software that you want. You just need an Axia node, which is balanced in and out. And anyway, long and short, we did that. RF problems gone, never to return.
So now you pick up the audio where the audio is made and don't have to ship it around the place.
Exactly.
I'm of the opinion that this is the only way to go for any new construction, and every place you can refit, just do it, because it will take the headaches away.
Even with modern analog audio routing switchers, in Greenville, Mississippi, we moved from a location that was very well done in the mid 2000s. It was well engineered for an analog plant. I couldn't have done it any better myself for an analog plant using state-of-the-art stuff, state-of-the-art analog stuff from 2005. I always felt that the audio wasn't quite pristine enough on the FMs that are there and the AM that's there. So when we moved, almost everything, there's almost nothing analog anymore. Little short wires from the satellite receivers into the nodes, and a little short wire into our older Omnia audio processors that don't have live wire. Other than that, everything is totally in the ones and zeros that go in are virtually the same ones and zeros that comes out. Now, unbelievable. I'm sitting at home here listening to my stations via streaming, and of course that's bitrate reduced. I get that, but oh my goodness, they sound so clear. Our talk shows, Herman Cain and Rush Limbaugh and Dr. Joy Brown, they all sound like they're sitting in my lap. Because you're so used to hearing just the vagaries of analog with 5532 ICs or whatever's hot nowadays in the analog world, and it just makes a difference to get rid of all that stuff.
Yep. Well, not only that, but also recognizing that an awful lot of AM plants were built not just in 2000, but built in 1982 or 1975 even in some cases. The problem is that the analog stuff just loses so much by the time it gets to the transmitter that there's nothing, you can't get a good stream out of it either. And that's one of the other aspects, is that you really want to have a good stream as well as have a good on-air signal.
This is a technique that I'm sure you're familiar with being a consulting engineer, but so often back in my early days working for Telos, I would go and demonstrate Omnia audio processing. And sometimes we'd put an Omnia processor in the studio and we couldn't make it sound good on the air. And I knew what it should sound like, and it wasn't sounding right. And I said, there's got to be something in your STL or at the transmitter site that is treating this audio badly. Tell you what, midnight tonight, let's put a CD player and an Omnia processor at the transmitter site and then go straight into your exciter and try that. Every time we did that, the station was cleaner than it had ever been before. Now it was, the fault was with different things along the line. The correction wasn't the same at any two stations, but we over time we build up stuff in our chains, and so glad to just simplify, or go all digital. Digital either is generally perfect or it doesn't work at all.
Well, in the computer world, you call it cruft.
Yes. Oh, that's a good word. Good word.
So we have equipment cruft in radio stations.
Hey, I got a feeling you and I could talk about this kind of thing all day, but we've got to probably jump on your passionate subject.
When you struggle with things that you find solutions for, or you find things to just stay away from because they'll drive you crazy, it's nice to pass that on, because new guys coming along, they're going to stumble on the same chunks of problem that you do. Like we were talking a little while ago about the problems of a RAID drive, particularly a RAID 5, which gets you performance and reliability, but the reliability is sometimes rather elusive.
Elusive. Yeah.
or an illusion. Maybe that's a better word.
Yes. Yeah.
So anyhow, one of the things that we wanted to get through is some of the things on the rulemakings that are underway at the FCC. And one of my buddies was down talking to the commissioners yesterday and came up with a couple of points. It looks as though the efficiency of the AM antenna restrictions are going to go away. I think everybody's been so universal about that the ratchet clause for nighttime interference is negative, or against the practicality, that's probably going to go away. I don't know whether they're going to change the protected contours. It probably makes sense. That's kind of
if you wouldn't mind, let's restate those couple three things in layman's terms. So the efficiency, does that mean I can have an inefficient antenna and it would be okay?
Right, and this really relates to size of antenna. So for a station that's anywhere below, I think it's 1340 or something like that, Anything that's not a Class C station, a local channel station.
Yeah.
The minimum efficiency is 283 millivolts per meter for a kilowatt into the antenna. And that means that the antenna has to be reasonably efficient. It's getting close to the efficiency of a quarter wave dipole or monopole over a decent ground system.
Yeah.
And the problem is that if you're talking a frequency like 700, you're talking 250 feet at least.
For the antenna.
250 feet means lights, and once you turn lights on, then you get into the situation that zoning won't let you put a tower up. And now if you lose your transmitter site, you can't put it up anyplace.
Ah, okay.
So you've got to get the tower heights under 200 for sure to get the lights off them. You've got to get, in many places, the tower heights under 100 feet because of zoning, because of the fact that it bothers neighbors.
Yeah.
And there are some technologies that will do low height antennas, but they don't work on the low end of the band at less than 100 feet. That's for sure.
Okay.
There's a company called Valcom, for example, that has a pole, a fiberglass pole that's wound with an antenna internally, which is used to get more efficiency out of a very short antenna. But it requires a full ground system, which means at 1 megahertz, you need 400 feet by 400 feet for the property. Yeah. And that's not always available, especially if you're trying to put it up somewhere in a city. So there are a number of technologies that are helping. The Valcom antenna helps about the height restrictions to some extent, but they don't work at the very low end of the band. They don't work down at 700 kilohertz or lower. The second part of it is that there's Kintronics has an antenna out that uses a whole bunch of phone poles and keeps the height at around 65 or 70 feet. And that has an advantage, but that also uses a fair amount of real estate. The actual space of the land is still substantial.
Now, with that one, you can use the land under the wires, though, right? Because
yes, unless you're talking really high power.
You could farm or you could graze cattle and that kind of thing.
Right. The concern on some of these is that you need to be careful when you get up to high power. A 50,000 watt radio station. When I built WWJZ, which is the Disney station here in the Philadelphia market, we used elevated radials so the farmer could farm the land under the tower. But we had to do a full radiation study riding on the tractor underneath each of the radials to be sure that at 50,000 watts, the area where the driver of the tractor is would remain safe.
Hey, I got to tell you, there's a shortwave station east of Nashville around the Lebanon, Tennessee area. I think it's I think the call letter is WWCR, but I could be wrong on that.
Well, that's one of them anyhow.
Yeah, and there's some rhombic antennas on the property there. And in the middle of the rhombic, the field is very, very high on the ground. And if the people there know that you're going to be driving out there, they'll give you their phone number and they'll offer to shut the transmitter down or reduce the power. So when you drive in, your car doesn't die, because that's a typical thing. You're driving through the middle of the rhombic on the gravel road and your car stops. And it turns out that not far from Nashville in Smyrna, Tennessee, there's a Nissan plant. Well, they bring their new models once or twice a year. They bring them up to that site and drive them around and see what dies, if anything.
It's a new type of automotive interference.
Yeah, I have a Toyota 4Runner, and it kept going, but the blower fan for the HVAC system, it went fast and slow as I was driving through this. It just went nuts. But the field has got to be very, very high there. I thought it was interesting though. It's useful to Nissan.
Well, one of the things that is one of the points I want to bring up is car radios. Not BMW, Mercedes-Benz. They're coming out with an all-electric, and they announced that they weren't going to put an AM radio.
Oh, actually, I thought it was. I thought it was BMW that.
Oh, maybe it was BMW. Okay.
Yeah.
Anyhow,
no AM radio.
They weren't going to put an AM radio in the car, and I got to thinking about this, and think about you're in your Lexus next to it. Although Lexuses have terrible car radios these days. Let's say you're in your Explorer next to it, and this car is going trashing on all over the AM band, and it's interfering with you, and you're stuck in a traffic jam next to this thing. So these are the kinds of problems that AM radio stations are suffering with these days. Another one is that a very popular brand of traffic light, traffic signals, red lights, green lights, and so on. They put out a lot of trash on the AM band, not across the entire band, at specific frequencies, at multiples of some clock rate that's in the system. And it's rather pernicious because the stoplight stops you there in a place where it interferes with your car radio.
Stop here and let me interfere with you.
So you're going to be stuck for a minute
that
listening to this buzz out of this radio, this thing. And I'm quite sure that it doesn't meet Part 15 standards.
Yeah.
I'm sure that it is. And quite frankly, I wouldn't care if there was a way that the municipalities that were putting them in would be able to set the frequency of the clock, whatever clock is causing the problem, to a specific frequency that avoided all the local radio stations. Because that would solve the problem.
I mean, a question comes to mind, and
nobody
I know
cares
we haven't
if
gotten
it puts noise 40 kilohertz away from the AM station in town.
I know that we're going to get to talking about digital on the AM band, but if you've got this kind of man-made noise, certainly it affects analog AM because you can hear it. That's what analog is.
Right.
But how bad does it have to be to start affecting some of the digital modes that have been bandied about?
Well, in the digital modes, there's a couple different things that are in there. When you look at, for example, the HD system, they use partial coding, where for example, the high frequencies are coded with, and I'm saying this just in a very general way. It's not exactly the way it really works, but it's to visualize it. The high frequencies that might not be as important for reception of a station. Yeah. What they do is they code those in a code which is not as protected, is not as robust as the mid-range frequencies that are critical importance. So what happens is you may lose the edge of the quality. You may end up with a roughness because that part of the signal is coded with less robustness than the part that's necessary to be able to understand what's going on and to be able to enjoy whatever the program is. So if Rush is going on about something that he's complaining about, you can still carry the conversation, and it might not be quite as clear, but Rush's voice might be slightly rougher than it normally is.
Gotcha.
Okay? So by having this coding that takes into account what's necessary for information, what's necessary for not being annoying, and coding the things that are just nice, like if you're trying to listen to the fine points of harpsichord, you can lose that and let it sound like a piano.
But so this is a graceful digital degradation that's built into the HD radio standard.
There are, in the HD radio system, trade-offs which have been made very specifically in the way that it's coded and in the way that not just the layer one, the hardware coding of the ODFM signals, but also the coding of the actual codec itself, the equivalent of AAC3, okay? Gotcha. Yeah. Where that is different in order to make up for the fact that you don't have real solid robustness all the time, and you need to make trade-offs and say, I don't want the signal to go away. Because if you just have it drop out, and that was one of the problems with the early DRM-30 system, was that you would be going along on shortwave and you'd be listening to this stuff and it just drops out and it stops and you lose 20 seconds until the skywave gets cleared up or until the noise goes away. You can't afford that in broadcast. So
Ted, in the debate over what to do with the AM band, of course, we read every few weeks or few months about this effort or that effort to mitigate this problem or mitigate that problem. And you mentioned some of the rule changes about the efficiency doesn't have to be met anymore, and about the ratcheting of interference. And I'm a little unclear about how that works. You're welcome to explain it.
Basically, what it says is if your station is a limiting station to another station at night, and you're going to make any change to your facility, that's at your volition, meaning that you want to change site because you want to change site because you want to sell it, not because you had the town shut you down or something like that. The FCC requires that you decrease the interference to the other station by 10%. And that's 10% voltage, which is 10% squared, or square root of 10%, which means that you take a hit. You could have a 50,000 watt radio station suddenly go down to, let's say, 30 kilowatts.
Yeah. Yeah.
Simply because of the ratchet clause.
Okay. Okay. So
Okay.
they've done away with this ratchet clause?
Well,
Is that it?
I'm quite sure it's going to go away in the next
Okay.
rulemaking. The comments have been universal. It was a stupid rule to begin with, and it would be stupid to continue with it. So the commission, I think, is listening to that one. And I've gotten on reasonable scuttlebutt that the commission's going to remove or relax the antenna efficiency rule, which we talked about before. I didn't get to the third type of antenna that's a small antenna, and that's an antenna called the CFA.
Yes, the crossfield.
Which there are people who say, oh, it just doesn't work. I know that it functions, but I know that the current design is broken.
Okay.
The ones that work are lucky, and they happen to have things fall into place in the right way. They can be made to work, but it needs more design. There's more design effort that is needed. I know where the design needs to be changed, but I don't know what to do to make it work right. I've been involved with the CFA folks, and if we can get that underway again, that project underway, I think that we can make that antenna work, and we can that it is possible to make it not only an efficient antenna, but a very small ground antenna. In other words, that the amount of ground that you actually consume will be a very modest amount of real estate. And it will cause little in terms of interference to PA systems and people's home organs and electronic stuff around the perimeter of the property. So we're looking at you can put a CFA antenna on half an acre instead of 4 as an absolute minimum.
Wow.
And that is very attractive.
I recall seeing pictures of the CFA antenna when it was ballyhooed in Radio World and other journals. Boy, it seems like 15, 18, 20 years ago we were hearing about these things.
And part of the problem is that everybody tends to want to model antennas with mini neck. And there's a problem in that you can't model currents that are flowing in a non-metallic or non-conductive area. And so the CFA antenna has what's called a D plate, which causes a magnetic field to be caused because of essentially the displacement current flowing in a capacitor. In other words, it only works with AC. It won't work with DC current.
Sure.
So you can't build the model using mini neck or neck to show how this thing works. And there are systems that could be written to fully model the antenna, but we're talking another full development, as much effort as went into building NEC in the first place, because it doesn't work on the same basis.
These antennas, if I recall, I saw several different designs, but they reminded me of a big thread bobbin or some kind of a big spool on its end.
Right.
A couple of cylinders stacked or something like this.
Right. One of the things that is absolutely necessary is that you don't build it on the ground. There were a number of them that were built on the ground, where you have a copper ground plane that goes out 30 feet or so in every direction, and then you have the D plate above the ground plane, and then you have this cone that comes up and looks like a giant funnel up above the top.
Okay.
And that style of antenna, if you put it on the ground, definitely will transmit very well at 30 degrees, 25 or 30 degrees above the horizon.
Oh, that's
not what you want.
Yeah.
So you're picking up the bottom of the lobe on the ground, which is where you want the signal to be going.
Yeah.
So that antenna has the problem as it stands, in that when you build it like the guy did in Tanta, a guy named Kabari, who runs the Egyptian program, in Tanta, he built 2 CFA antennas on the roof of buildings. And he happened to build them in just such a way that beam, instead of being up at 30 degrees, came down to like 5 degrees above the horizon.
Okay.
Now it worked, and it actually worked pretty well. The measurements that I think it was a Swiss made showed that the antenna worked about as well as a quarter wave dipole or a quarter wave monopole. But they built it in other places like Australia, and it didn't work worth beans.
Yeah.
Now, I made a ham radio CFA antenna, and it did work. However, I could only talk to stations 300 to 400 miles away. If you went a couple miles away from where I was, you couldn't hear it at all on 40 meters. And if you were closer on high-angle skywave, you didn't hear it. And if you were further away, you didn't hear it either. So the antenna was a very early, basically it came right out of the Haitley patent, the original Haitley patent. And I built it just the way that was set up. And I fooled with it for about 3 days before I finally got it to transmit at all. At 25 watts, I had it arcing and sparking a couple times before I got it to work. But it did work. However, it only talked 300 to 400 miles away.
Not so good for selling local ads to local.
Yeah. I could talk to Pittsburgh with it.
Yeah. Hey, I want to remind our viewers and listeners you're watching episode 228 of This Week in Radio Tech. Ted Schober is our guest, and we're talking about the AM band improvements, both incremental and maybe some. I'd like to talk to Ted after our commercial here about the possibility of blowing up the AM band and see where that goes. Our show is brought to you in part by the folks at Telos and the Telos ProStream streaming audio encoder. I've got one right over here, and it's right here. It's this 1RU box. And in fact, Andrew Zarian's got one as well. This, in fact, 1,000 people out there have them. This box, what it is, it does audio streaming. It ingests audio, analog or live wire audio coming in. The AES version of it will be coming out in a few months. And it takes that audio in, and it has built into it Omnia audio processing, a beautiful 3-band processor. You can set it aggressively or gently. There are presets that come with it. And it does have a fantastic look-ahead limiter. And it's exactly what coded audio needs. If you want to get loud, you can't do clipping, and you shouldn't do just an ordinary textbook look-ahead limiter. You need to do one that is going to mitigate intermodulation products. Ooh, that's a big word. But that's what this one does. It predicts and mitigates intermodulation products that otherwise a look-ahead limiter would cause. And then after that, inside, it has 2 encoders. You can set these for different algorithms. You can set one of them for AAC and one for HEAAC or V2. You can set it for MP3, and you can set them for different bit rates. So you have 2 different encoders built in, and then you have 4 different outputs. So you can send these streams that you make with the encoders, you can send them to geographically diverse replication servers. You can do whatever you need to, but you can send them to 4 different places. Maybe you've got a Wowza server. You can send another one to a Shoutcast server, send another one to an Icecast server, send another one to a CDN like Live 365. And it'll work with all these things at the same time. Plus, it also has a built-in confidence streaming server, which actually will feed about 50 different users. So if you know that your streaming needs are small, that you don't have hundreds of listeners out there, you may not need a content distribution network partner, or you may not need a stream replication server. The ProStream all on its own will stream to about 50 different users. So if that's your limit anyway, that'll work just fine. We use them at our radio stations along with some Omnia AXE. Of course, I use one right here, and I can highly recommend it. The hardware is solid. It uses a Linux operating system that is just as solid as can be, and you don't have to suffer with Microsoft updates. You don't have to suffer with the hackers potentially getting into it. This is a very low interest thing to hackers, and it's Linux, and it just has the parts of Linux in there that it needs to run. Now, if you would check it out, I'd appreciate it. If you need to do stream encoding, this is just a great box to have. Oh, it also will do metadata. It's got a built-in metadata parser that you can set up a script to parse your metadata and make the title and artist and all that come out correctly. It'll ingest data from a metadata aggregation program. So if you want to run announcements on your stream or reference album art, you can do all that too. Go to the web and check out telos-systems.com and look for the ProStream streaming audio encoder. It's in use at some very big facilities and lots of little ones too. I love it. All right. Episode 228 of This Week in Radio Tech. Our guest is Ted Schober, and Ted and I are having a fascinating discussion about AM radio, which, is kind of a snoozer to some people. But, man, Ted, in the big cities, San Francisco, Chicago, New York, Houston, Dallas, Atlanta, AM is alive and well. And in some of these cities, an AM station typically will hold the top or the second place in the ratings. But in small towns like Greenville, Mississippi, where we have a little AM station, it's tough.
Well, that's definitely a consideration. One of the things that is a factor, though, is that there's a number of places where AM stations are the only game in town, and they do quite well, thank you. There's also a lot of AM stations that are community focused, very community focused, and they are also doing very well. The problem with this is that those stations tend to have a fairly high cost of doing business. So you have to maintain a certain minimum gross in order to be able to handle it. So, for example, there's a little radio station outside of New York City. It's not a New York City station. It's a Bergen County station. Mm-hmm. They have 30 employees.
Mm-hmm. Quite a bit for a standalone.
For a 2,500 watt AM radio station.
Oh my goodness!
On the high end of the band.
Wow.
With a directional antenna and their daytimer.
Oh my goodness!
And they make money.
They serve their audience well.
Of course, they have people like friends like Soupy Sales used to come there, and John Zachary, and fairly big names would come there, simply because it was such a cool place to go to. And it still is an absolutely cool place to go to. And would you believe they're still using cart machines?
Oh my goodness! Wow!
And then another is in a fairly small town. Let's see, the town is about 60,000 people. There's a kilowatt daytimer. They have a nice FM translator, and they do a news talk format. They've got Rush. They got a couple other good names like that, and they're doing quite nicely too. They're doing around $1 million or so a year, and they've got 6 or 7 employees, and they are the information station for the community. Now, there's only so many slots for that. You can't make every radio station be able to do that, because when you have FM stations that are doing the community radio slot, when you have FM stations that are doing the religious radio slot, when you have a market that's too small to garner enough ethnic listeners, you run into the problem that there may not be an opportunity big enough for an AM radio station to grab a chunk of the action that will make it viable. And there are some radio stations that just need to go away because they can never achieve a competitive position relative to the other players that do the same thing, the Class B FMs or Class C2 FMs that are in town. And an AM station can't actively compete. I know I had a friend down in Florida who had an AM FM combo, and he sent in the license for the AM because he couldn't find a hole. He was under the Jacksonville umbrella. He couldn't find a hole of programming. He was doing the community radio on his FM. So what was left for his AM?
Yeah.
So he and his town was too small to do ethnic radio, and Bible Broadcasting was in there with an FM, and then there's 6 other religious FMs up in Jacksonville. So there was no marketplace for him. And those stations don't need to stay on the air anymore. And I think most clusters have got a station of that category, and I got something great to do with that. Let's get into digital AM.
Yeah, and I want to preface it with this thought. So I am part owner of 2 AM stations right now, and one of them is a very niche black gospel format, a lot of localism there, and it's still popular in its little town of Indianola, Mississippi. It used to be owned by Eddie Fritz Jr., by the way. And then I have another AM that has an FM translator, and I think that we wouldn't mind if that AM went away, or if we were allowed to transmit digital on it and the receivers didn't show up for 2 years. I think I guess what I'm saying is, from a small station owner point of view, it wouldn't bother me to blow up the AM band, especially if I had a crutch to get me through some period of time while radios came out, like a translator or a channel 2 to channel 6 FM, something like that. But then there are these legacy AMs that, they want to just keep on chugging the way. Sure, they'd like to take advantage of whatever comes along, but they don't want to blow up what they got now. So I've always felt that AM needs just some kind of transition and then blow up all the analog. You tell me what you've got in mind, and I'm all ears.
Okay, well, the first thing that I think is really important to do is we turn off hybrid HD on AM. On FM, it does its job. You've got the multi-HD channels, and it's gonna eventually take hold, and eventually there will be some brave broadcaster who will turn off the analog on FM. Right. On AM, there's no reason to operate an HD signal because, first of all, the codec that you have to use in hybrid is compromised. It doesn't have enough bandwidth to do anything except voice right. And even voice, it doesn't do as well as it should. In terms of robustness, it falls apart before the analog signal falls apart.
Yeah, so why have it?
You have this large area where you're shifting back and forth between analog and digital. Now, if you have a first-generation exciter, and I suppose even the later ones, if you don't watch them, if that exciter reboots, now you have 2.5 seconds worth of delay of latency between the analog signal and the digital signal because they don't automatically self-align. So you end up with a horrible sound where people are repeating themselves. Rush says the same phrase over and over again because you keep jumping back and forth between the analog and the digital signal over a substantial part of your sales area. This occurs between like the 1 and the 2 millivolt per meter contour, or if there's noise, perhaps even closer.
Okay.
So you can't afford to do that. So you're hurting yourself, first of all. The second thing is you hurt your neighbors. Your second adjacent neighbor is getting trashed if he's around town. And that's not fair. It's inappropriate. I know of a station that's outside of New York City that is absolutely being trashed by 2 50 kilowatters in New York City on their HD sidebands. And the station is just not viable because of that. Even though it would be otherwise a reasonable 25,000 watt radio station, it's got a small fraction of its coverage area that it reaches in the most desirable part of its coverage area.
Okay.
So my personal feeling, HD hybrid goes away. The sooner the better.
And there are very few of those stations on the air. Now, you mentioned 2 in New York City, but my impression was there weren't that many of them on.
Well, I know here in Philadelphia, I know we've got KYW still running it.
Okay.
And I think WPHT is still running it.
Okay.
So I think we got 2 of them in town. DAS was running it for a while and they shut it off. There are quite a few. If you want an HD exciter, I'm sure you could buy them real cheap.
Okay.
They're sitting next to the power sides.
Would you suspect that there are fewer than 100 or fewer than 200 AM stations that are running HD on them now?
I would think it's probably someplace around 100 are still currently running it. And
by the way, anyone that's running HD on AM right now is in the hybrid mode. They're running their analog.
Yeah. You'd have to have an STA or an experimental authorization to run in digital only mode. Now, I have to say I've done work for Ubiquity, so I've loved the guys. Some of my best friends work down there. But what I did was I did an experimental authorization in Frederick, Maryland for a daytime only digital station to run for Ubiquity in Frederick, Maryland. And this was up at 1640, I think it was.
Yeah, I remember hearing about the station.
And, the X-band stations at 10 kilowatts, they don't go very far. They're kind of like a kilowatt mid-band station in the daytime. The signal on the expanded band just doesn't go that far unless you have wonderful ground conductivity. They work well in Houston, but in the Northeast, they just don't have enough coverage area to be able to do what they need to. Those stations need to be 50 kilowatts a day and probably 5 or 10 kilowatts at night in order to be viable. That's my personal feeling. and I had made comments to the FCC to that effect too, that they should change the nature of what the expanded band stations. Let them go to 50 kilowatts. There's no reason why not. And they may have to do some critical hours work, but that's a different story. The other part is that when they took and turned on the digital only, I guess you'd still call it IBOC, but it's the HD digital only signal, the MA1 or MA2 signal, and I'm not sure which one they were using. Mm-hmm. They took and did some driving tests, and they took a conventional, I think it was a Jensen receiver, if I'm not mistaken, and then they took their test stuff in a minivan, and they drove from Frederick out Route 70 to Route I-81, and then they went up to Harrisburg. Okay. Now, in between I-81 and Harrisburg, there's some mountains. So 1640 doesn't go across mountains very well.
Oh, yeah.
So north of Hagerstown, it's like it kind of fades away. Well, in the digital-only mode, they ran all the way to Harrisburg, and they ran out of daylight, and they had no dropouts whatsoever.
Really? Oh.
None at all. And this would be the case for any, well, I can't say that every system would work equivalently well. And that's something that experiments need to be done head against head, taking and looking at MA1, MA2 in environments with high noise, in environments with low signal levels, in environments with interference from other digitals and from analogs. And do the same thing with the DRM-30s. And each of the DRM-30 versions, because there's different versions. There are versions of DRM-30 that are no longer viable. In other words, back when they were using older codecs, forget it. DRM-30 wasn't worth having. But now that they're running the Opus codec in DRM-30, it has the possibility of very high performance and multi-channel, which I don't think that there's any real, doing 2 or 3 stereo channels on an AM 10 kilohertz wide band channel has an option in any of the HD plans. Okay. But in DRM-30, you could readily run a multi-channel operation using Opus codec if you switched down to voice. Okay. You can't run music multi-channel, or you could use. You could run one music channel, one music channel, and one voice channel on Opus, but you could run 3 or 4 voice channels if you chose to on Opus.
With AM digital only mode, with HD digital only or DRM, what kind of bit rate?
We're talking right now with the voice part of Opus.
Yeah, the Silk codec. Yeah. What?
So that's what it sounds like.
What kind of bit rate can you get out of AM with our channels now, whether it's HD or whether it's DRM-30?
As I remember, I think the number, the total, the layer 2 bit rate on the MA1, I think was 48 kilobits per second. Okay. I'm not positive about that. I think that's what it is. And the MA2 was something a little different. It was a while since I looked at it, and quite frankly, I wouldn't be surprised if the HD folks, Ubiquiti, has upgraded since the documents that I saw. Yeah. And I'm also not supposed to say a whole lot about it because I did sign a non-disclosure.
What about DRM-30? What kind of bit rate are you getting through?
DRM-30 depends upon which one you choose. See, if you're in Europe and you have a 9 kilohertz spacing, you've got a whole different animal than here. So there's a DRM-30 that's 4.5 kilohertz wide. That's 4.5 kilohertz wide. That's the whole channel. Yeah. There's one that's 5 kilohertz wide. Yeah. There's one that's 9 kilohertz wide, and there's one that's 10 kilohertz wide. Okay. So there's a whole family of DRM-30s. There may be more that I'm not even privy to. I just was looking at the documents from 6 months ago.
Well, I was curious because, one technology that didn't seem to really take off, and we at Telos played with it quite a bit, and we really liked it, and that was this MPEG Surround, where you have a standard stereo channel, which, by the way, could be transmitted with analog, with any kind of digital, just you had your stereo channels. And then you had Fraunhofer got it down to 6 kilobits, a 6 kilobit shorthand for the steering information
Steering
for
channel, right.
the channels,
Mhm.
and you could lose the steering information and still have stereo.
Right.
But if you had the steering information, and by the way, it didn't have to be quite time locked. The decoder would match it back up through some kind of
because there was a
smartness.
time code in it. Yeah.
And so if you had, let's imagine with AMHD they had 56 kilobits available, you could end up transmitting 50 kilobits or 48 kilobits of honest to goodness whatever their codec is, or if you want to use AAC ELD or HEV2 or something, and then you'd have 6 kilobits to give you could get a not bad sounding and fully separated, no smoke and mirrors tricks, of 5.1 surround sound on AM. You could do this, and it actually would work and sound. It would sound absolutely as good as HEAAC V2 at 48 kilobits. There's no there's no loss for steering that audio
I'm glad
around.
you said HEAAC too, because the MP3 at that speed is not anything.
Oh no, and MP3 is 20 years old, and it's kind of old hat. Even Greg Oganowski was on our show a year ago and said, "Stop using MP3."
Well, the problem is that if you're using Microsoft Internet Explorer, they don't want to talk anything but MP3. If you don't have Flash, you have problems with the HEAAC.
Yeah.
So if you got to put plugins into your browser, it's a problem. And then going the other way, Firefox won't take MP3s, and you got to have an external player. So we have to get MP3 has a problem of patents. Okay, HEAAC has licenses. The only codec I know of that is completely license free is Opus.
Yeah,
there's the problem is implementation is still not throughout. I mean, let's see. Firefox will play it naturally. I believe you have to put a plug-in to Internet Explorer. So it's coming, but it's not quite there yet.
Well, so we only got a few minutes left. Let's focus us in on what you might imagine a transition to a digital AM band might look like.
Right.
Can you
That's
help
the
us?
crux of the whole matter. Yeah. How do we get there? Because it's like you jump off a cliff. But if you have a station that's got a very good translator, then the opportunity is presented to you that, especially if the FCC would give you a cut on, not having to pay so much for your regulatory fees, and maybe you get some other breaks elsewhere. Maybe what you do is you say, I'm going to take and cut my AM signal to full digital, or maybe I'll take and cut it to full digital all night and kind of give people a taste of it, and then consider down the road a little bit going to full digital all the time. The other thing is, if you have a combo and you've got 3 FMs and 2 AMs in town, you take your weaker AM and kick it over to full digital, okay, and then take the full digital signal and duplicate what's on the AM. And now what you've got, because the digital signal will go further than the analog signal does, you now have a weak signal that's not weak anymore. Okay. You also, many stations have many groups have stations that are never going to make money from here on out. They don't have a market position, so cut them full digital and put them onto the signal that's your strong AM, and build ratings that way. Put your best product forward on digital as a duplicate, especially if you can't get a translator.
Would you see in the U.S. An all digital AM band being all HD, all DRM, or a combination with receivers that could get both?
Well, it all depends. Until this year, it wouldn't be practical. But this year, there's 2 companies that have come out with all system radios. One is a 2-chip system. The other is a 1-chip system, both of which will run on little batteries. Now, the issue, the thing I'm concerned about with the all system radio is that both of these systems, you code in what systems you want to work in it. In other words, you say, I want this mask, I want that mask. Okay. What we really need is we want those systems put in Flash. Okay, and it will increase the cost a little bit, but not that much. I mean, think about how much an Arduino chip costs. That's got a lot of flash in it.
Okay.
You know, so my point is that we really need to go one little generation from where we are. So right now you can buy a single chip, which will do AM, FM, HD, AM, digital, full digital.
Yeah.
HD, FM, DRM 30, DRM plus, all in one chip. And it's a battery, because it only does one system at a time. In other words, and once it's tuned to a station, it knows what that station is. It's only using electronics that are needed to do that. And it's pretty much all the same electronics. You come in, you have a down converter, you have an IQ decoder that goes into DSP. The DSP is all software. And every system is ODFM. They all have the same basic building blocks. The only difference that one system is different in that the receiver manufacturer has to pay a royalty to Ubiquiti for the HD system. And that is something that concerns me, because I like the guys at Ubiquiti and I'd like them to be successful. But if a receiver manufacturer is selling a chipset that's going to sell for 60 cents and it's going into a $300 radio, and the problem is that Ubiquiti wants to charge $2 to put the HD in, are they going to get left behind?
Yeah.
So that's the concern that I have. It's a marketing issue as much as a technical issue. Both systems work perfectly well when you get away from the hybrid. Both systems work perfectly well. And the thing that people were trying to do with channel 5 and 6, it looks like FCC is not looking real good at doing that. I think it'd probably be a great idea, but the problem is the FCC's packing the UHF band. They're not going to do anything until that's done. And I don't know how long that's going to be before that happens. It's going to be several years at least. And if we don't do something to make AM live through these bad times, AM may not make it. That'll make it. The big cities and everybody else will just kind of fade away, because you are suffering with noise. Now, by the way, the digital signals are more robust against noise.
Sure.
For one thing, you're running with at least 30 seconds worth of latency. You get stuck under one of these traffic lights. You may be gone before the signal's gone, and it picks up, and you don't even know that it's there.
Gotcha. Yeah.
Okay. So those are the things that you worry about. I do see a big difference in what we will end up with as what we see as radios. They may be hidden from what they used to be. We may find that every radio is delivering multiple streams simultaneously, both digital, medium wave, and FM. And for example, you get traffic for where you are. But it just folds right in. That the radio is smart enough to buffer up traffic from 10 different places, figure out which one is the traffic that should go where you happen to be, and you only hear the traffic for where you're going.
Gotcha. Yeah, especially if it's talking to the GPS system that's built in the car.
Right,
It knows where you're going.
So I don't really see the likelihood that car radios are going to be important anymore.
Car entertainment systems or car radios?
This is going to talk by Bluetooth, or hey, here it is. This is going to talk by Bluetooth to your car entertainment system.
Yeah, I do that now, and
because if different people drive the car, everybody wants different stuff.
Yeah, that's true.
This is the thing that should make it official.
But don't the car manufacturers want to profit mightily on in-car entertainment systems?
Bose will let you spend lots of money on speakers and amplifiers.
Yeah, well, that's true. Okay, you can still spend a lot of money there. Ted, I've got to put us on hold.
Going back to the handset as well.
I've got to put us on hold
for the handset. Yeah,
for just a minute. We got a break for our last sponsor message, and when we come back, we got time for a final thought, and that's going to be about it. We've blown through a little bit more than an hour here. Hey, you're watching or listening to This Week in Radio Tech, episode number 228. It's been a fascinating show with Ted Schober, professional engineer, and a guy who talks about the AM band and how we can fix it and how we can maybe blow it up and make it all better. Our show is being brought to you in part by the folks at Lavo. Their website, lawo.com. And you're going to want to check out the Crystal Clear Virtual Radio Mixing Console. This is really cutting-edge technology. It is so cool. Yes, it does AOIP. There's an option for Ravenna and AES 67 compliance. It's a multi-touch screen work surface that you have. The mixing console itself lives in a 1RU box that's off in a rack somewhere, and then networked to that box is another small computer. In this case, they typically marry it with an HP computer that has a multi-touch 10-touch touchscreen. And the application that runs looks like a gorgeous radio console. You can move faders up and down. The buttons are context sensitive for what you're doing right then. So if you need to adjust mic processing or set a mic gain or make an auto mix of several mics, the buttons know what to do when you're in that mode, and you just get the things that you need to. So you don't have to look at a whole bunch of stuff all at the same time. It's very context sensitive, and this makes it great for operators. The Crystal Clear virtual mixing console has 8 faders on it. But it has 24 inputs. So if 8 faders for any given show or any part of a show. There's 3 stereo mixing groups, like of course program 1, program 2, and a record bus. So you can do production at the same time that you're on the air. It has an integrated cue system, of course, with metering. Programmable scene presets, so you can have a morning show, an afternoon show, a show that's set up just for the ball games. Precision stereo PPM meters, and big time of day clock. You can sync it to an NTP server. Again, 24 sources are available in a mix of analog and AES digital. 8 of them, and microphone too, 8 can be simultaneously active. As I mentioned, there are AES EBU digital inputs and outputs. And power supply redundancy is available, plus GPIO for on-air lights and cutting the speakers off and all that kind of stuff. Low noise mic preamps, high performance too. This is just a gorgeous console. It may be exactly what you're looking for. And so I'd like you to check it out. Download the brochure from this website. It's at Lavo, LAWO.com. They're a German company. They have offices in the U.S. and Canada and other countries around the world. And you might know that the folks that I work for, Telos Alliance, we have partnered with them on a few little projects, and think very highly of these folks. So it's Lavo.com. Look under the radio consoles, and then look for the Crystal Clear console. Check them out, Lavo.com. Thank them very much for their sponsorship of This Week in Radio Tech. Ted, we've just got a couple minutes. We got to wrap it up. What's your summary here, sir?
Well, actually summarizing, AM needs to get changing to make things work. But one more point that I want to get into is just about translators and also AM synchronous. The idea of putting more than one translator on the same frequency in the same area in order to fill in the AM service area with a good FM signal. And this is practical now. There are people who've tried it and been successful. Years ago, there were people who tried it and went down in flames because they didn't properly sync the audio. It works much better in mono than it does in stereo. So that's a concern on FM. On AM, synchronizing was tried even back in the 20s and 30s with poor effect. But people have figured it out now, and the guys down in Puerto Rico have done a wonderful job running synchronous stations down there. We have one up in Lowell, Massachusetts that's working, and they're quite happy with it. And what happens is you end up causing a lot less interference from low-power multiple stations. And over in Japan, they found using 3 or 4 stations to cover an area was more efficient than trying to just use 2.
I guess you do end up with real estate issues, though, because instead of one side, you need to then make arrangements for
part of it
sides.
is I've been working on a very small AM antenna for 1 to 50 watts ERP, which would be on a roof.
Yeah, and this would be a solution.
Like a 15 or 20 foot tall antenna.
Yeah,
and I have a prototype in the shop, but I haven't finished it yet. And if that plays the way I think that it will, I think there's some opportunity to make very low power fill-ins that will put relatively high levels of RF in the places where the noise is really bad. And that will solve a lot of the problems for AM.
Ted, if folks need to reach you, where is a good place, a good point of connection for you? Your website?
Well, my website is radiotechniques.com. RADIOTECHNIQUES, all one word, .com.
Yep.
And then the office number is 856-546-8008, and I'm an extension 111.
All right. Ted, I want to have you back on again to give us some more thoughts on this. We barely scratched the surface of these issues, and I appreciate you jumping right into it. I hope our audience members kept up along. I almost did the whole time, and it really would be exciting to see the AM band transition over to a digital medium and have great quality, and these legacy broadcasters we can continue to operate and even maybe make room for some more folks to be successful. I would love to see that.
Mm-hmm. Very good. Well, I think that the FCC is in a mode where they're looking to do whatever they can to make things work. I know that on an experimental basis, shortly there will be an opportunity to ask to have your station run at least part-time, digital only. I think that there's also the case that we'll be able to do that without a big rigmarole and great amount of effort, because it's good for the industry to try this stuff out. And I don't know whether we should go DRM-30 or whether we should go Ubiquity MA1 or MA2 or whatever new thing they've got in their pocket they haven't told us about yet. But I know obviously it would be easier to turn a station on to the digital system, because you could take your old exciter and get Ubiquity to give you a new program load, and you'd be all set. So I think that's certainly easier to try out. And for experiments, we could do that. And I think we should have a shootout. Put multiple systems on one station, and go and let all the engineers who are the highfalutin engineers for the groups go out and drive them and see how they fly.
I'm all for that. We got to draw it to a close. Our guest has been Ted Schober. His website is radiotechniques.com. I'm Kirk Harnack. Our show has been brought to you by the folks at Axia and my favorite little piece of software in the world, the Axia IP Audio Driver. It turns computers into AOIP devices. Just awesome. Also by Telos Systems and the ProStream streaming audio encoder. It's a powerful little box. I got one right here. Just love the thing. And also by Lavo and the Lavo Crystal Clear Virtual Radio Mixing Console. Thanks very much to the GFQ Network. Tune into the GFQ Network for shows that are about all kinds of crazy stuff, including Mad Men and the Friday Free-for-All, and who knows what the tech and who knows what else. But if you look at their website at gfqnetwork.com, you'll find out all about it. Thanks to Andrew Zarian, and we'll see you next week on This Week in Radio Tech. Bye-bye, everybody.